Hello, this is H.K. Bhangade from Department of First Year Engineering, SMD College of Engineering and Research Center, Avon. We are discussing DC circuits, which is a topic from Basic Electrical Engineering. Today, we'll discuss about the electrical resistance. Now, the resistance, we always know it is nothing but the property of the material which opposes the flow of the current. So, the electric field is proportional to current density within a resistive material. Thus, voltage is proportional to current. The circuit element used to model this behavior is a resistor. So here the circuit symbol for this resistance is shown, and it is always denoted by a capital letter R. And the unit of measurement for the resistance is volts per ampere, and that is always used as a ohms in the memory of ohm. So the current flowing in the resistor is proportional to the voltage across the resistor. So whatever the voltage you apply across the resistor, depending on that voltage, the magnitude of the current will be varies, because the voltage applied is nothing but which will act as a driving force for the current in that particular resistor. So V is equal to IR. It is nothing but your Ohm's law. So where V is the voltage, I is the current, and R is the resistance measured in ampere and ohm respectively. Now, let us understood this concept of resistance with your water. So there is the analogy between the water with the electrical elements. Since you can't see electricity, we can't see. We only imagine that there is through the wire current is flowing. Okay, but by open eyes, it is not possible to see the electricity. It is usual to think of the flow of water as being like that of electric charge. So we shall see water analogies for a number of electrical devices, capacitors, diode, etc. So water analogy for charge, the quantity of water, say 1 gallon, is like 1 coulomb of charge. Water analogy for current flow is flow rate of water, say 1 gallon per second, is like 1 coulomb per second, that is 1 ampere. Electric potential difference, that is voltage, is like the difference in the pressure in a hydraulic system. The model for a resistor, and increased resistance reduces the current that flows for a given voltage, is like the effect of putting a sponge in a water pipe or crimping it. So look in the figures, we again understood what exactly is the sponge acting as a resistance. So here is the wire, there is a pipe, right? Now this is a circuit node. It is shown different branches are coming together at a particular junction, that is called as node. Then it is symbol for the resistance. So it is a symbol for resistor, and is a pipeline, and sponge is there, and it is a constriction. This sponge will act as a constriction, and which opposes the flow to the water. So resistor and schematic symbol is there. Two alternative water models corresponding to these two elements is there. Now resistance of an actual resistor. How to find the resistance of the material? Now, a piece of wire if I have given in your hand, then how to find its resistance? So for that, the formula is there, R is equal to rho L upon WT. So the resistance is always equal to resistivity length upon cross-sectional area. Okay, so here material resistivity, whatever the material, depending on the material, resistivity changes. Then length of the material or the wire, okay, and the width of that material, that is being always considered. So it is always rho L upon A. It is R is equal to rho L upon A. Where A is the area, and here as the shape of is rectangular shape, that's why it is area is always equal to W into P. Area is always equal to W into T, that is rho L upon A. Next is electrical conductance. Now, conductance is the exactly opposite to that of resistance. It is the reciprocal of resistance. So conductance is always indicated by a capital letter G, and units is Siemens or mHos, mOhms. So example, consider an 8 ohm resistance. Then what is its conductance? Simply conductance is reciprocal of the resistor, so it is 1 upon 8 Siemens. Then short circuit and open circuit concept in a circuit. Now wire, we will use it as a short circuit. So R is equal to 0. So no voltage difference exists. No voltage difference exists. So all points on the wire are at the same potential. When all points are on same potential, that time there will be no difference, potential difference. So current can flow as determined by the circuits. So AR, it is open circuit. Its resistance is infinity. So no current flows. So the voltage difference can exist as determined by the circuit. Then circuit nodes and loop. So node is a point where two or more circuit elements are connected together. So it is a common point. And a loop is formed by tracing a closed path in a circuit through selected basic circuit elements without passing through any intermediate node more than once. So that is nothing but the loop. Thank you. Next time we'll discuss the next topic in DC circuits. Till then, goodbye.